We have a quadratic, and we want to graph it by finding the vertex, whether it opens up or down, and using some point plotting. Okay, now for the opening up or down, we look at the coefficient, or the number multiplied by the x squared. And it's nothing listed here, so that's understood to be a 1. Since that's positive, that means this is going to open up. Okay, the vertex. So remember, the graph of a quadratic is a parabola shape, so it's a U shape. The vertex is going to be that significant point where your parabola turns. So the x value for the vertex is found by using the formula negative b over 2a. B is what's multiplied by just the x to the first, and you have to include the sign. So there's a negative with the formula, and then the b value is negative 6. Then the denominator 2a, a is that coefficient of my x squared, so that's again a 1. And if I simplify this, negative and negative is positive 6. 6 over 2 is 3. That's only half of my vertex. I need the y coordinate as well, and we obtain that by putting your x value into the formula. So this will be 3 squared minus 6 times 3 plus 5. That is 9 minus 18 plus 5. 9 minus 18 is negative 9. Add 5, and I get negative 4. So the vertex for this one is at 3, negative 4. We can go ahead and start the graph. My vertex is at the point 3, negative 4. And I've already determined that this will open up. So it's going to be something like this with my U shape. And I'm going to use point plotting to try to get that a little more accurate. Okay, with point plotting, I want to pick numbers to plug in both to the left and the right of my vertex. So I'm just going to make a chart here. Okay, so if I move to the right of the vertex, I'm going to plug in both 4 and 5. When I put 4 into my formula, I get 4 squared minus 6 times 4 plus 5. I can do that by hand, but I think with this one I'll go ahead and use the calculator. So that is 4 squared minus 6 times 4 plus 5, and that gives me a negative 3. So if I tie that together, ooh, you got to watch because these numbers are similar to each other. You got to watch the order. My x is 4, my y is negative 3, so that would be here. Okay, now what happens when I plug in 5? So 5 squared minus 6 times 5 plus 5. So again, I could evaluate that by hand, but I'm going to go ahead and use my calculator. Wait a minute, something didn't happen right there. 5 squared minus 6 times 5 plus 5. And we get 0. Okay, now what about values to the left of the vertex? So if I move over 1 to the left, my x value will be 2. And if I move over 2 to the left, it will be 1. I might plot one more point here just because it's a common point. If I plug in 0 for my x value, that's going to give me the y-intercept. Okay, so if I put in 2 into my function, I get 2 squared minus 6 times 2 plus 5. 2 squared minus 6 times 2 plus 5, and I get a y value of negative 3. When I put in 1, I'll get 1 squared I know is 1, 6 times 1 I know is 6, so I can shorten that a little bit. And oops, I knew that was wrong, and I'll tell you why I knew that was wrong in just a minute. I put in a minus instead of a plus for the 5. Should come out to be, can't plug it in right, 1 minus 6 plus 5. Should get 0, yes, 0. And then let me do this other one, 0 squared minus 6 times 0 plus 5. 0, 0, this is just going to give me 5. I don't need a calculator for that. Okay, so now, how did I know that I had typed this one in wrong? Well, let's look at what happens here. When the x value is 2, the y value is negative 3. I moved one away from the vertex to the right and to the left, and I ended up with the same y value. That should happen because of symmetry. And the same thing would happen here. When I moved 2 to the right of the vertex, my y value is 0. So if I move 2 to the left of the vertex, I should get a y value of 0. So that's something you can use to double check yourself. Okay, now that's certainly enough points to get my graph, but again, intercepts are always good points to find. When I put in x is 0, I get the y-intercept at 5. Okay, now I'm sure my scale is not perfect here. I'm just going to do the best I can to draw in this graph of a parabola. Oh, and one more thing. Because of that whole symmetry, where else are we going to get a y value of 5? Well, this is when I had an x value of 0, which was 3 to the left of my vertex. So if I move 3 to the right of the vertex, which would give me an x value of 6, that should give me a y value of 5. And I'm not going to write it down, but we can check it. So that would be, provided I can type it in correctly, 6 squared minus 6 times 6 plus 5. Aha, y value is 5. And there is the graph of our quadratic.